Dear maths aspirants, right now I have the Leon Hard Euler 1707 to 1783, and the chapter what I am going to discuss, chapter 12 of plus 2 level, Introduction to Three-Dimensional Geometry. Here is the three-dimensional geometry introduction. So mathematics is both the queen and the handmaiden of all sciences. E.T. Bell given this quote. Here is the quote you will see here, and chapter is here, chapter 412, Introduction to Three-Dimensional Geometry. Here you will see introduction. You may recall to locate the position of a point in a plane we need two intersecting mutually perpendicular lines in a plane. These lines are called the coordinate axes, and the two numbers are called the coordinates of the point with respect to the axis. In actual life, we do not have to deal with points lying in a plane only. For example, consider the position of a ball thrown in space at different points of time, or the position of an aeroplane as it flies from one place to another at different times during its flight. Similarly, if we were to locate the position of the lowest tip of an electric bulb hanging from the ceiling of a room, or the position of the central tip of the ceiling fan in a room, we will not only require the perpendicular distances of the point to be located from two perpendicular walls of the room, but also the height of the point from the floor of the room. Therefore, we need not only two but three numbers representing the perpendicular distances of the point from the mutually perpendicular planes, namely the floor of the room and two adjacent walls of the room. The three numbers representing the three distances are called the coordinates of the point with reference to the three coordinate planes. So a point in a space has three coordinates. In this chapter we shall study the basic concepts of geometry in three-dimensional space. For various activities in three-dimensional geometry, one may refer to the book, A Handbook for Designing Mathematics Laboratory in Schools, NCERT 2005. Figure 12.1 and the subtopic 12.2, coordinate axis and coordinate planes in three-dimensional space. Consider three planes intersecting at a point O such that these three planes are mutually perpendicular to each other. Figure 12.1, these three planes intersect along the lines x dash ox, y dash oy, and z dash oz, called the xy and z axis respectively. We may note that these lines are mutually perpendicular to each other. These lines constitute the rectangular coordinate system. The planes XOY, YOZ, and ZOX, called respectively the XY plane and the YZ plane and the ZX plane, are known as the three coordinate planes. We take the XOY plane as the plane of the paper and the line ZSOZ as are known as the three coordinates plane. We take the XOY plane as the plane of the paper and the line as ZSOZ as perpendicular to the plane XOY. If the plane of the paper is considered as horizontal, then the line ZSOZ will be vertical. The distances measured from XY plane upwards in the direction of OZ are taken as positive, and those measured downwards in the direction of OZ are taken as negative. Similarly, the distance measured to the right of ZX plane along OY are taken as positive, to the left of ZX plane and along OY dash is negative. In front of YZ plane along OX as positive, and to the back of it along OX dash as negative. The point O is called the origin of the coordinate system. The three coordinate planes divide the space into 8 parts known as octants. These octants could be named as XOYZ, XZOYZ, XZO, X dash OY dash Z, XOY dash Z, XOYZ dash, XZOYZ dash, X dash OY dash Z dash, and XOY dash Z dash, and denoted by 1 2 3 dot 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 8 respectively. Then I would like to say you the next course of action will be coordinates of point in space. Having chosen a fixed coordinate system in the space consisting of coordinate axis, coordinate planes, and the origin, we now explain as to how give a point in the space we associate with it three coordinates x, y, z, and conversely given a triplet of three numbers x, y, z, how we locate a point in the space. Given a point P in a space, we drop a perpendicular PM on the xy plane with M as the foot of this perpendicular. Figure 12.2 is, then from the point M we draw a perpendicular ML to the x-axis, meeting it at L. Let OL be X, LM be Y, and MP be Z. Then XY Z are called the XYZ coordinates respectively of the point P in the space. In figure 12.2 we may note that the point P all XYZ lies in the octant X or YZ, and so all XYZ are positive. If P was in any other octant, the signs of X, Y, and Z would change accordingly. Thus, to each point P in the space there corresponds an ordered triplet XYZ of real numbers. Conversely, given any triplet XYZ, we would first fix the point L on the x-axis corresponding to X, then locate the point M in the XY plane. That XY are the coordinate of the point M in the XY plane. Note that LM is perpendicular to the x-axis, is parallel to the y-axis. Having reached the point M, we draw a perpendicular MP to the XY plane and locate on it the point P corresponding to Z. The point P so obtained has then the coordinates XYZ. Thus there is a 1-to-1 correspondence between the points in space and ordered triplet XYZ of real numbers. Alternatively, through the point of the P space, we draw three planes parallel to the coordinate planes, meeting the x-axis, y-axis and z-axis in the points A, B and C respectively. Figure 12.3. Let OA is equal to x, OB is equal to y and OC is equal to z. Then the point P will have the coordinates x, y and z. We write P whole x, y, z. Conversely, given x, y and z, we locate the 3 points A, B and C on the 3 coordinate axes. Through the point A, B and C, we draw planes parallel to the x, y, z plane, zx plane and xy plane respectively. The point of intersection of 3 planes, namely ADPF, BDPE and CAPF is obviously the point P corresponding to the ordered triplet XYZ. Observe that if P whole XYZ is any point in the space, then XYZ are perpendicular distances from YZ, ZX and XY planes respectively. Note the coordinate of the origin O and whole Z00. The coordinate of any point on the x-axis will be as x00 and coordinates of any point in XYZ plane will be as 0YZ. Remarks is here. You will see the remarks coordinates. In next video I will provide you some examples. Here you can see. Till then, thank you for watching the video.